Hello. So today we'll be doing vectors in 2 dimensions. So we'll just be answering a bunch of those questions in vectors in 2 dimensions, and I'll just be showing you the tricks of this topic. Let's just start. So there are a few things that I'll be breaking down as we move along this topic. It's quite of an easy topic. You just need to understand one of two things. Oh my god, let me just close the window because there's like noise outside. Okay, let's actually start. I'll be teaching you a couple of stuff along the way as we are moving. Okay, let's talk about. So the first question says, calculate the magnitude of the resultant force. Now, let's talk about something that is called the resultant. The resultant, right? So on physics, whenever they want you to calculate the resultant of something, know that it is either you add or you minus a couple of stuff, right? Just like in this question, they say calculate the resultant, right? So I just want you to understand what they mean by this. Let's say we are having force 1 that equals to 7 newtons. That is a vector. And we have force 2 that is also a vector that actually equals to -3 newtons. So when they say calculate the magnitude, when they say calculate the resultant of these two vectors, so when they say calculate the resultant, it means that, okay, so the resultant, which happens to be the F net, it is going to be the sum of F1, and then you're going to add it to F2. So in this case, F1 is 7 plus, and F2 happens to be -3. So we're going to get that the resultant force is actually 4 newtons. So this is the F net, or the resultant. Okay. Well, so on this topic, however, we'll be dealing with a different resultant in most of the times. So the resultant that they would want us to deal with also includes the components of a vector. Components of a vector. All right. So what do we understand about the components of a vector? So a vector have two components. Vector have two components. So a vector have two components. So the first component is going to be the x components, and the second component is going to be the y components. So this is the x components, and this is going to be my y components, right? So what do we now understand about this x and y components? Because it seems like I'm breaking into like a new barrier or something. So, okay, let's say we are having a triangle. As you might have learned from trigonometry, this triangle has is something like this. And we know that this is our hypotenuse of the part, and then this is our y part, and this is our x part. So what this means is this is our x component of the vector r. So we're having this vector r, and within the vector r, this is going to be our x component, and this is going to be our y component if we are having the vector r, right? So how do we actually find the x and y component? If we are given that the vector r equals to 3 newtons, and then this is going to be our angle theta, right? What's going on? Yeah, this is going to be our angle theta, and this is going to be our angle k, all right? So how do I actually find the x component of this triangle, or the x component of this vector r, using the angle theta or using the angle k. So there are situations where you're gonna use the angle theta or use the angle k depending on which angle is much easier to use on that scenario. Let's start if we are using the angle theta, right? If we are using the angle theta, how do I find my x and y components of of this r vector? So I just want you to know this, right? Because this is something that is actually done in trigonometry. So I'll just want you to know this because I don't want to explain trigonometric concepts on vectors, although it's quite useful. So I'm just going to tell you the stuff that you need to know. If you are using this theta, right? If you are using this theta, this is your triangle, and you are using this theta, how can you find the x component? So the x component is going to be r, that is the resultant vector r, the cos of theta. This becomes your x component. But what about if I want to find my y component using theta? So my y component using theta, it's going to be r, the sine of theta, all right? This is going to be r, the sine of theta. But let me just label this triangle perhaps. This is my adjacent, right? This is my opposite, and this is my hypotenuse, right? So if the angle that you're gonna use is on the adjacent side of the triangle, these are the formulas that you're gonna use to find the x and y components. So I'm gonna repeat this. If the angle that you want to use, if the x components, let me just emphasize this. If the x component is actually on the okay, let me just say if the angle that you want to use, is on the adjacent side of the triangle, that is the x component side of the triangle. These are the formulas that you're gonna use. But what about if you want to use the formula, the angle k? If you check, I hate noise, honestly speaking. I incredibly hate noise. But what are you gonna do? It's the world after all. Okay, if the angle that you use is on the opposite side, how do you find the x component? So it is going to be r, the sine of k. For y, it's going to be r, the cos of k. So if you see, we have just like swapped, right? We have just swapped. So it really depends on which angle you're gonna use. So I'll just be explaining this as time goes on. But how do we find the resultant? So let me just draw a question where we're gonna find the resultant. Let's say you are given the following. You are having this wonderful thing, right? We are having this wonderful thing, and then you are being told this is theta, and this is k, and this is 3 newtons, right? No, this is not what I want. You are given that this is 4 newtons, and this is, I don't know, like 7 newtons or something. And they say find the resultant R, right? Find the resultant R. How do you find the resultant R? So in every case, please note, this is your y component, and this is your x component, right? This is your y component, and this is your x component. How do you find the resultant? So the way you find the resultant is you're going to add the x component and you square it, and then you add it with the y component and then you square it. So this is just the theorem of Pythagoras. You already know the theorem of Pythagoras. So you're going to say, okay, my resultant is going to be the x component is 4, it's 7, and then you square it, and the y component is going to be 4, and then you actually square it, right? So that is how you actually deal with the things. So if you use your calculator, you're gonna find the resultant of the vector r. And as I've said, when it comes to resultant, you need to add something. So at this point, you have added these two And because it's actually on a triangle, you had to use the theorem of Pythagoras to actually find the resultant of r. So on another word, it means that whenever you have to find the resultant of r, you first need to have the x and the y component. And at this point, you were already given the x component as 7 and the y component as 4. So you had to add the x and y component and use the theorem of Pythagoras. Let's try to find another clue. Let's say at this point, you are given this as 30 degrees. This is your 90, this is your 60 degrees. And you are being told that r is actually equals to 7 newtons. And they say, find the x and y component. How do you do it? How do you find the x and y component? Well, let's use this angle. This is 30 degrees, right? So because the angle that we want to use is actually on the adjacent side of the triangle, we're going to use the following. We want to find the x and y component. So for the x component, which formulas are we going to take from? I'm going to take this from here. Because you see this angle, theta, let's say this is theta, and we're having x and we're having x, right? So because we are using this angle, these are the formulas we are going to use. So it means that my x equals to what is r? You see we are having r, and at this point r is 7 newtons. I'm going to write 7. And then we're going to put cos, and then we're going to put the cos. But what about what is theta? So at this point, theta is going to be 30 degrees. So that is how you find your x component if the angle that you're using it's actually on the adjacent side of the triangle. What about if we want to find y? So y, it is the same thing. It's r, and then I'm going to find my r as 7, but we're just going to use sine. And then my sine is going to be 30 degrees, right? And then if you hit your calculator, you're going to find the values. So try to do it as a homework to try to find the x and y component using the angle that is not on the adjacent side of the triangle, but rather on the opposite side of the triangle, and see if the answers that you get are the same. If you like compare these ones. Okay. So let's say you are actually having the x and y component. Let's pretend as if we don't know the resultant, and then they tell you find the resultant. We pretend that we don't know the resultant is 7, but how do we find the resultant? So if you check, we were given the x and y resultant, and then we just added them and used the theorem of Pythagoras. So that's what you're going to do. You find the resultant, and then you're just going to add them. What is the x component? Is 7, the cos of 30 degrees. What is the y component? Is 7, the sine of 30 degrees, and then you square it. I'm 100% sure if you hit this on the calculator, you're going to get 7. So that's how you find the resultant. Now let's just go back to our original question. Okay. They say calculate the magnitude of the resultant of FB and FC. Which one is FB? This is FB and this is FC, right? So what is actually happening? You find that these two are actually on the x. If you look at this, this is the x, and then this is going to be the y-axis. You know about the x and y-axis, right? So they want us to find the resultant of FB and FC. So because, what's happening? Okay, so because FB and FC are on a straight line, which is the x-axis, they are lying on the x-axis. It means that you just add them without having to do anything, because we don't have the y component to use the theorem of Pythagoras on. So it means that the resultant of FB and C, it is going to be minus 8 plus 6. Why did I say this is minus 8? This is minus 8 even though they did not tell us, because it is actually on the negative side of the Cartesian plane. We know that anything that has to do with the x-axis on this side is actually a negative. So this is just going to be negative 8. So this is going to give us, what answer is this actually going to give us? So let me just remove this. Okay, so this is going to give us negative 2 newtons. All right, we just add this 2. Okay, now the question says the net horizontal component. What is horizontal and what is vertical? Well, the x-axis, it's actually horizontal, and then the y-axis, it's actually vertical, right? So y equals to vertical, right? While x equals to horizontal, right? So they're telling us the net horizontal component for the forces FA, FB, FC, and FD equals to 1.25. So what are they saying? They are saying that when we add, because they say horizontal and this is horizontal, so they're telling us that for this force FA, FB, FC, and FD, when we add their horizontal component, right? When we add their horizontal component all together, it gives us a value of 1.25 newtons. So what does this mean? We're being told that the horizontal component, the sum means addition, sum of the x components, sum of x components of what? Of FA, FB, FC, and FD equals to 1.25 newtons. So how can I find the x components of FA, FB, FC, and FD? So in another way, they're trying to tell me that if I can add the x components of FA, FB, the x components, FC, the x components, plus FD, the x component, this should give me 1.25 newtons. So let me just look. What is the x component of FA? You look at FA, right? This is going to be my FA. So my FA, I don't know this angle, but I do know this angle. What is this? These are angles on a straight line. So what does this mean? We all know that angles on a straight line add up to 180 degrees. So let's just name this angle K. So because this is an angle on a straight line, I'm sorry, this is done on Euclidean geometry or on geometry on mathematics. That's where you find it. It says that the angles on a straight line, K plus 150 degrees, this should give us 180 degrees. So it means that K is going to be 30 degrees. So we know that K equals to 30 degrees. So how can I find the x components of FA? Well, if you construct this to be a triangle, you find that this is going to be y, this is going to be x, isn't it? And we know that K equals to 30 degrees. How can I find the x components of FA? So it means that the x components of FA is going to be what? If you check, we're going to have FA. On the other questions we did, we were having R. So FA is 5. So that's just going to be, okay, it's going to be FA, the cos of K, right? So what is FA? FA is 5. The cos, what is K, is 30 degrees. So that is the x components of what? Of FA. What about the x components of FB? Let's try to find the x component of FB. Which one is FB? This is FB, right? So by the way, this answer that we've got, that x equals to 5 cos 30 degrees, it is actually this value. It is actually the length from 0 to this point. From 0 to this point, it is the x components of FA. So the value is 5 cos 30, the length from 0 to here, right? It is the x components. But let's try to find the x components of FB. Well, the x components of FB, well, when you look at FB, it is just on the x-axis, right? XB is actually on the x-axis, so you don't have to do anything. You know that the x component of FB is just going to equals to minus 8 newtons, right? because like here it is, FB is just on the x-axis, it's minus 8 newtons, right? So this is going to be of FB, right? Let's try to find that of FC. What is the x component of that of x of XC? So we're just trying to find that the x component of FC. It is also on the x-axis. Can you see it? It is also on the x-axis. So the x component of the force of C, it is also going to be what? 6 newtons. It's just going to be 6 newtons. So this is the x component of the force FC. Well, let's try to find the x component of the force FD. Right? Let's try to find the force of the x component FD. How can we find the x component? So let me just try to draw a dotted line here. This is going to be this, right? So we know this is going to be x and we know this is going to be y. But how can we find this angle that I'm gonna call theta? How can I find the angle theta? Well, I know that this this angle is 90 degrees. This angle, it is a 90 degrees. So if this is 30 degrees, it means that this one has to be 60 degrees. So these things are just, these little tricks are found on mathematics in Euclidean geometry, right? So if this is 30 degrees, means this is 60 degrees. So how can I find the x component of FD, right? So the angle that I'm using, it is actually on the adjacent side of the triangle. You see, I'm not using this one on the opposite side of the triangle. I'm using the one on the adjacent side of the triangle. So it means that x is going to be what? FD, the cos of theta, right? And what is FD? And I find that my FD is what? Oh, I do not know what is FD, right? They did not tell me. So it means that I'm just going to have FD, but I do know that I'm going to have the cos of what? Of theta. But what is theta? Theta is, what is theta? Theta is a 60 degrees. So I should do another example using the other method, like trying to find the x coordinates using this triangle, using this angle that is going to be 30 degrees. But I do not want to confuse you. I want you to do that on your own and see if you're going to get the same answer, because I feel like I will be confusing you by feeding you a lot of information here. So we know that the x components of FD, it is just FD, the cos of 60 degrees. Let's try to rewrite this. What is the x components of FA? The x components of FA was 5 cos of 30, right? Let me try to find this. What is 5? I'm just going to write 5, the cos of 30 degrees. This is just going to give me 4.3. So I'm going to have 4.3. Let me say plus. What is the x components of FB? So here's FB. The x components of FB is what? Is minus 8 plus. What is the x components of FC? It is going to be positive 6 plus. What is the x components of FD? This is the one that I found to be FD, the cos of 60 degrees. And we have been told this just equals to 1.25 newtons. So what does the question say? So the question say calculate FD, right? So the question say calculate FD. How do we calculate FD? Well, we do know that this is unknown, right? So let's just try to add this. So I'm going to add 4.3 minus 8 plus 6, and it gives me 2.3 plus FD, the cos of 60 degrees, that equals to 1.25. So I'm just going to take this 2.3 onto the negative side. So FD is going to be 1.25 minus 2.3, which equals to minus 1. Oh, by the way, FD, it is still FD, the cos of 60 degrees. That's going to equals to minus 1.05. So I need to divide both sides by the cos of 60 degrees. So my FD is going to be divided by the cos of 60 degrees. And I get the value of what? Did anyone try to find it? And I get the value of minus 2.1 newtons. Okay, and I get the value to be 2.1 minus 2.1 newtons. Oh, how stupid are we? Look at FA, right? FA is where? Is on the negative side, so this should have been minus 5, like for FA, because it's just on the negative side. Where's FA? This is FA. It should have been like minus 5, so this means this is minus. Now we just messed up with the minus only, so minus 4,3 minus 8 plus 6, it is going to be, so this is not 2.3, it is minus 6.3. So I'm going to take this 6.3 into the other side, so we're going to have 1.25 plus 6.3. that is going to give us, so instead of having negative 1 point this one, I'm going to have 7.55, and then I'm going to divide this by cos 60 degrees, divide by cos 60 degrees, and what do I get? I get a value of FD that is equals to 15.1 newtons. How did I see that I made a mistake? Because the answer that I got an FD that has a negative answer, and I was like, wait, this is not on the negative side because the x component is positive, right? The x component is positive, so there's no way I'm going to get a negative answer. So because I realized I did not put a negative in here, now I get a positive answer, which makes sense because this is also on the positive side. Okay, now the question says calculate the resultant force acting at point O. What do you remember about the resultant force? So the resultant force, they want us, because on this question they say calculate the resultant force acting at point O. So in another word, they want us to add all these forces and find their resultant, right? So what did I taught you about finding the resultant force? What did I teach you about finding the resultant? Finding the resultant, it's all about finding the x and y components. I'm trying to reach out for that paper. It's all about finding the x and y component, and then you put them on a square root and then you square them, right? Using the theorem of Pythagoras. So in another word, even on this question, add all the x components and add all the y components, and then you find the sum of them and then you just put them on a square root. So how are we going to do this? Well, for this question, we already know the x component, right? So I already know that the x component, because look at this, we added all the sum of the x components. You see, we added the sum of the FA component, FBX component, FCX component, and FDX component, and it gave us 1.25 newtons, right? So it means that the x component is 1.25. So in another word, now we need to add all the, oh my god, this thing makes a lot of noise. Now we need to add all the y component of this thing, right? We need to add all the y component of this thing. Well, what was k? K was 30 degrees, I remember. So k was 30 degrees. So let's try to find the y component of FA, right? So the y component of FA, what is it going to be? It's going to be 5, the sine of 30 degrees, because I'm using this angle, right? Let's go to FB. Does FB have a y component? No, FB doesn't have a y component because it is just on the x-axis, right? Let's try on FC. Does FC has a y component? No, it's the same thing as FB. They're just flat on the x-axis. Now let's try to find the y component of FD, right? The y component of FD. How are we going to find it? So the y component of FD is going to be, what is FD again? we've just found that FD is 15.1, the sine of what? The sine of 60 degrees. So if we add these two, if we add, remember this 5 is a negative, remember from here, right? It is a negative. So if we add minus 5, the sine of 30 degrees, plus 15.1, the sine of 60 degrees, that is our y component. So I'm going to have minus 5, the sine of 30, plus 15.1, the sine of 60 degrees. And I get a value of 10.58 newtons. So in another word, I now have the x components and I now have the y components. So the resultant, it is just going to be 1.25 squared plus 10.58 squared. 1.25 squared because it's the x component and the y of 10.58. And then I just hit my calculator. What do I find? I find this is going to be 10.7 newtons. Well, this will be the end of this lecture regarding this. So I feel this will be the most important lectures because you need to understand what I was explaining here, so that when we go into other questions, you don't have to, I don't have to re-explain everything that I've explained into this lecture. Otherwise, enjoy the rest of your day.